going to look at man and barrel first. Okay, so kind of zooming in on this. So what we have is we have a man that is pulling a barrel. And to some extent, we are going to ignore the fact that this is a pulley, okay? A pulley is a type of simple machine that would actually help this person pull the barrel, okay? But we want to kind of ignore that aspect of it, okay? We want to just kind of think of that he's just pulling this object, okay? Something else I want us to think about. Would it make sense that if the barrel was heavy enough and the man was light enough, would it make sense that the man would come off the ground? Like that the barrel would maybe like fall down a little bit more and the man would come off the ground? Could we see that logically happening here? Okay, so those are the kind of things I want us to be thinking about this picture before we start drawing the free body diagrams, okay? So the first thing we're going to do is the barrel, because I think the barrel is just the simpler of the two to sketch. So for the barrel, we have an FG that is negative, I guess 65? Yeah, negative 65 newtons. And then we have a tension force that is also a magnitude of 65, but it's positive for this one. Oops. Okay, so remember, any forces, I'm just gonna erase this really quickly. Typeface is just so large. Hold on a second. So any forces that are up or to the right are positive. Any forces that are down or to the left are negative. Okay, so we just want to remember that as we're going through this, because it's not that like it's just this random physics convention that keeps us deciding if something is negative or positive here, okay? All right, so then for the man, we want to start with his downward force, which is just his gravity force. So negative 800 newtons. All right, so here's where we need to start kind of rationalizing our way through this. So here's the deal. This guy is he is stationary. The barrel is also stationary, okay? If you are pulling on something, that object is also pulling on you. And if there's no movement, those forces are balanced, okay? So because of that, I can assign a pull force here because he's pulling, right? So he's pulling, so that means that the object is also pulling back on him, okay? The reason I'm not assigning this as tension force is because he is not like, he's not swinging on this object, right? Like it's not like the rope is attached to like a swing set or something like that and he's holding onto it and kind of swinging back and forth. Like that's not what's happening. He's actively pulling on it, so that means that the rope is pulling back, okay? So we have a pull force of 65 newtons. Now we also need to think about the fact that this man, again, is not moving, so his upper and lower forces are the same. They are identical, okay? So when we have his normal force, because he has normal force, he's resting on the ground, we have to do the math and actually think this through, because the 65 and whatever number is the normal force need to add up to the magnitude of 800. So 800 minus 65, we get 735. So that's what his normal force is going to be. We are going to treat this as stacked objects because we have a man stacked on top of a platform. Okay? So we're going to always start with the top thing, and the top thing here is the man. So we have his shape, and we're going to have a downward force for his gravity force. And that's just Fg is equal to negative 800 newtons. He is sitting on a platform, so it's a lot like he's sitting on like a chair or something. So he's just going to have one normal force up, and that normal force is going to be equal to 800 newtons. Okay, then over here with the platform. So when we have stacked objects, we always start with the gravity force because that's the easy one. Gravity force is equal to negative 150 newtons. Again, I'm just going to give myself some more space here. And then we also have the push force. Oops, I drew that way too long. Should be about the same. So the push force of a stacked object is always going to be equal to the magnitude of the normal force directly above it. So the magnitude of the normal force for the man is 800 newtons. So the push force would be negative 800 newtons. Okay, so now we get to the tension forces, okay, because he's on a swing. He's on a swing, so we have two tension forces. I'm actually going to hold off on drawing these arrows for a second. I want to think through the magnitude before I draw the arrows. So our magnitude of the tension forces is going to be equal to the magnitude of the downward forces. So 800 plus 150 divided by 2 is 475. That's how we get the tension forces. Okay, so tension forces always go along the rope or cable or whatever you have. But you need to split it up according to how many you have. Okay, so we do not have one tension force that's equal to 950. We have two tension forces that are equal to 475.